Today's lesson is on lesson 11.4 on compound events. The objectives today is finding probabilities of what's called mutually inclusive events. We're going to talk about at least probabilities, and we're going to use some Venn diagrams to help us solve some of these today. First, a little reminder on your note sheet. You can kind of write these down, but the word and, if we see that in probability, that was like our questions that we had last week on Friday with independent versus dependent events. We multiply the probabilities together. So if you see the word or, we add them. We're going to see a lot of the or questions today. So we do start off with a couple vocabulary words. The first one is what's called mutually exclusive events. These are events that cannot both occur in the same trial of the experiment. So one good example of this is if I roll a dice or flip a coin. The outcome of me rolling a dice, there's no overlap of that flipping a coin. They're totally mutually exclusive events. Versus inclusive events, those are ones that have overlap. So if I roll a dice here, and let's say the first case, I want to see a number greater than 4. In the second case, I'm looking for a number that's even. Well, numbers greater than 4 on a dice would be a 5 or a 6. Even numbers on a dice are a 2, 4, or a 6. So since there is an overlap of 6 that I counted twice, that's an inclusive event. Later, we're going to have to subtract out those probabilities after we add them. But let's first take a look at some mutually exclusive cases. So here, mutually exclusive, as a little reminder, there are two events that can't occur at the same time. So I got a little example again up there for you to remember. The Venn diagram below would just look like two circles that don't intersect at all. So if you want to copy this little Venn diagram into your notes there, that's what our case looks like as a Venn diagram. Venn diagrams are simply just little circles. And what we're going to do is we're going to write in what those actual outcomes are in that little circle when we start trying some of these problems. So as a little reminder, you're going to see some probabilities that involve the word or in the word problem. So this is where we add the probabilities together. Now you do not have to do this by hand. You don't have to do this using common denominator work. You can actually use your calculator and just make sure you change it to a fraction by pressing the math and pressing enter on that arrow fraction. Let's take a look at our first example. Here we roll a dice. Find the probability of rolling a number less than 3 or a number greater than 4. So the word or means I would add the probabilities. As a separate events here, the first event we'd consider would be a number less than 3. Well, in that case, numbers less than 3 is just a 1 and a 2 on a dice. The next case, the event B, would be considered the number greater than 4. On a dice, only numbers greater than 4 would be a 5 or a 6. Since there are 6 total outcomes rolling dice, if I add these probabilities together, it would be a 2 out of 6 plus a 2 out of 6 chance getting the second case. Since there's no overlap, I can treat these separate probabilities. So notice there's a common denominator already for us, so we can add straight across the numerators, so it becomes a 4 out of 6 chance, which reduces to a 2/3 probability. See if you can try this one. It says a drink company applies one label to each bottle cap: free drink, free meal, or try again. A bottle cap has a 1 in 10th probability of being labeled free drink and a 1/25th probability of labeled free meal. First, I want you to explain the mutually exclusive, why the free drink and free meal are mutually exclusive. And then the second part is I want you to find the probability of that happening. I know there's a part C on your note sheet, so the part C I also want you to find is what's the probability of getting the try again label, which is not listed in the problem. Remember, probabilities always add up to 100%. Take a moment, see if you can try these. You can use your calculator. We don't have the actual number of outcomes here. These are the actual probabilities. So when you see the word or, we would add those two numbers together. But see if you can use your calculator to find out the reduced answer. Good luck. The first case, why are these mutually exclusive? Well, we only have 3 types of bottle caps. We have free drink, free meal, or try again. There's not a bottle cap that has free drink or free meal and free drink under the one bottle cap, right? So since they're separate bottle caps and there's not sort of a both of them under one bottle cap, then we can consider this mutually exclusive. The probability of setting up a free drink would be, looks like we had a 1 out of 10th probability of getting a free drink, and then the word or means I would add the other probability of a 1/25th chance of doing this. If you use your calculator, you will get a 7 out of 50th chance total of getting that free drink or a free meal. So the last case was, what's the probability of getting the try again? Remember that if we have a 1/10 and a 1/25th probability of getting the other two, then I guess the other remaining, right, because all the probability has to add up to 100%, the other remaining 43 out of 50 would have to be the try again if the 7 out of 50 are the other two. So that's just using our complement event of doing the 1 minus 7/50ths on our calculator. You can flip over the note sheet, and we'll talk about inclusive events next. So inclusive events, good to write this vocabulary word down. This is where we add the probabilities together, but this is where they're both happening at the same time. So our formula that we use, and I want you to kind of write this formula in the box there, is this. We still add the two probabilities together, that's the word or, but with all these next cases, you're going to see that there's some kind of slight overlap in the mix. And that little notation of that little upside down U, that represents what we call the intersection. So take a moment to copy these vocabulary words down as well as the formula, and we'll take a look at our next few examples involving inclusive events, which are a little bit harder than the mutually exclusive events. All right, let's take a look at this first one. So it says, of 220 people who came into a deli on Friday, 104 people bought pizza and 82 of them used a credit card. Half of the people who bought pizza used a credit card. What is the probability that a customer bought pizza or used a credit card? So we have our two different events here. The first event in our first circle is going to be people who bought pizza. And then the second circle, we have people who used a credit card. So right away at the beginning, we know that 104 out of the 220 people are ones who bought pizza. So we can write that probability in the first circle. The next case, in the credit card scenario, we know that 82 out of the 220 use a credit card. So what we have to do is we have to think about what the intersection of that people who had pizza and used a credit card would be the intersection there. If we read this next sentence, it says half of the people who bought pizza used a credit card. So this means half of the people who bought pizza, which is half of the 104 who bought pizza, they used a credit card out of that group. So that means 52 out of the 220 were people who had a pizza and used a credit card. So if we set this up, our formula is that we take the probability of pizza plus the probability of people who used a credit card, and we're going to subtract out that little intersection of the probability of pizza and used a credit card. Probability of pizza was 104 out of 220. Probability of credit cards was 82 out of 220, and we're going to subtract out the intersection of the 52 people who used a credit card. If we do this on our calculator, you get a total of 134 out of 220, which reduces to, looks like a 67 out of 110 chance probability. Let's take a look at our next example. It says here we're rolling one die. It says find the probability of rolling an even number or a prime number. And the next one says find the probability of rolling a number greater than 3 or an even number. So the first case, we have our two events. We'll draw our circles here. And event A is rolling an even number. And event B is rolling a prime number. So we'll have to talk about what a prime number means. But the first case, event A, rolling a dice, we have just 1 through 6 to roll. So an even number would be a 2, 4, or a 6. So we have a 3 out of 6 probability there. rolling a prime number. Prime numbers are numbers that are only divisible by 1 and itself. So the first prime number we think of is a 2, and then it'd be a 3, 5 would be a prime number, 7, I think the next one after that would be 11, and so forth. So numbers up to 6 would, I guess, be a 2, 3, or a 5, so you have a 3 out of 6 chance there. So notice by writing the sample space out, we can see that we counted 2 twice in our sample space. So the 2 would be considered the 1 out of 6 overlap there. So the setup here would be the probability of getting an even number, which we have a 3 out of 6 chance, plus the probability of getting a prime number, which we also got a 3 out of 6 chance, but we have to subtract out that probability of both happening, which was the 2 overlap, and that's a 1 out of 6 choices there, the 2. So if I add these up and subtract the 1, I get a 5 out of 6 chance total. The next case, I have a number greater than 3, and then the other case would be a number that is even. So even numbers again would be a 2, 4, or a 6, so we still have a 3 out of 6 chance, like the one before. But a number greater than 3 would be a specifically 4, 5, or a 6. That's still a 3 out of 6 chance of getting a number greater than 3 rolling dice. So notice if I write out the sample space, I see that I counted 4 and 6 twice in both of these. So since that's an overlap, that's 2 out of the 6 would be the overlap. So the setup here would be I have a 3 out of 6 getting a number greater than 3, plus, because I see the word or, 3 out of 6 chance of getting an even number, but I have to subtract out the 2 out of 6 chance, which was the overlap there. So if I add these up, I get a 4 out of 6, which reduces to a 2/3 probability. So now I want you guys to try some of these on your own. The first one is rolling a dice, so you got your choices of 1 through 6 there. And then the second one's drawing a card. So if you don't remember the sample space, just try number 1 first on your own. You can pause the video and see if you can try number 2 as well. Good luck. If you tried the first one, the 2 Venn diagrams would be a number less than 3, and then the other case would be an odd number. So if you think about rolling a dice, numbers that are less than 3 are specifically 1 and a 2. An odd number on a dice would be a 1, 3, or a 5. So if you notice the overlap there, looks like I counted 1 twice, so that 1 would be the overlap. So in the first case, I have a 2 out of 6 chance for the 1 and 2, and the word or means I add a 3 out of 6 chance for the odd numbers, but I need to subtract out the overlap of that 1 I counted twice. If I add these up and subtract the 1 out of 6, you get a 4 out of 6 probability, which becomes a 2/3 chance. In the next case, a little bit harder if you don't have the sample space in front of you, but drawing a heart, that's 13 out of 52 cards. So our sample space would be drawing a heart. It's going to be hard to actually put all the hearts in the circle there, but the other sample space would be a face card. So we just write the number 13 out of 52 here, because there's 1/4 of the deck is all hearts. And then for face cards, we're talking jacks, queens, and kings. And if you think about those cards, there's 4 of each. So you have a 12 out of 52 chance of getting a face card. The overlap there was specifically the jack of hearts, the queen of hearts, and the king of hearts. Trying my best to draw a heart there. So those would be all the overlap that are both hearts and face cards. And so those would be 3 out of the 52 that we counted twice. So the setup here would be 13 out of 52 hearts out of 12 out of 52 face cards, and we counted all the hearts that are face cards twice, so that would be the 3 out of 52 total cards. If you add these up and subtract the 3, you end up getting a 22 out of 52 chance, which reduces to an 11 out of 26 probability there. All right, the last part today, and then I'll let you guys work on the practice and homework quiz. These are a little difficult. These are called at least probabilities. So another unique word problem that we'll come across on our test coming up in a couple days. Here we're trying to find at least that happening. So the easy way to doing it is setting up and finding out what the probability of the event not happening, and then do just 1 minus that. So I'll give you a moment to copy down the formula. but we're going to take a look at 2 of these, and then I'll let you get to some practice here. So here there are 5 students in a book club. Each student randomly chooses a book from a list of 10 titles. What is the probability that at least 2 students in the group choose the same book? So there's the word choose here, which kind of reminds us of a little combination. In fact, if we think about these 5 students as sort of spots here, 1 through 5, the first student, I guess, could pick any book they want because that would be different than everybody to start. So this first student has a 10 out of 10 chance of picking a different book. But the next student can't pick the same book. So the next student would only have a 9 out of 10 chance of picking that one. And notice I'm multiplying these probabilities because we're assuming that everybody is choosing a different book each case. So this would be assumed that it's an and scenario. So in the second case, the third one, the student would have an 8 out of 10, and you can kind of see the pattern. The next student would have a 7 out of 10, and the last student would have a 6 out of 10 chance. This would be the probability of everybody choosing something different. So if I do 1 minus that, that's going to be the answer of at least 2 choosing the same book. Now again, I wouldn't expect you to do this by hand. I would expect you to use your calculator. So on your calculator, you would tap, I would first type in what this answer is as a probability and press enter. And then I'd do 1 minus that answer on my calculator to get the actual probability. We're going to leave these as decimals here because it's going to be kind of hard for us to change a lot of these as fractions. So if you did this on your calculator, you're going to get a, I think this ends up being a 0.3024 probability of the event not happening. So if I do 1 minus the 0.3024 on my calculator, I will get an answer of, looks like 0.6976. So this would be the decimal form, and as a percentage, that would be 69.76% of them choosing the same book. So I'm going to have you guys try one. I know I only went over one with you guys, but see if you can pause the video, try this one on your own, and we'll take a look at how to set this one up in a minute. Good luck. So here we have 15 choices. You got to take it into account when we're doing the probability of picking something different, but here we only have 3 friends, so we're going to put 3 slots out. The first friend has a 15 out of 15 chance because they will pick something different as a first pick. Nobody else has picked yet. But then the next person only has a 14 out of 15 chance, and then the last person has a 13 out of 15 chance of picking something different. So again, if I do 1 minus the probability of this happening, then that will be my answer of at least 2 having the same class. So I think if you multiply these probabilities together, you get a 0.809 probability. So if you do 1 minus that answer, it's going to be a 19.1% chance of that happening. So this concludes our lesson. So hopefully you had a chance to copy down those notes on the note sheet. Tomorrow we're going to review everything to get ready for that quiz on Wednesday, but your homework is to do the worksheet. Check the key as you try some of those and do that homework quiz that's out there. Good luck, and we'll see you tomorrow.